Right, this is Andrew, MTR1201. This is the final assignment, task 4, the control module. So here we've got the Millie's flying fish, no structural changes from the previous, and we'll load up the programs and have a look at them, and then we will have a chat about what I found with it. And start the fan and upload the program. So it's initially got it starting at an angle of 0. Once it's loaded, wait 2 seconds and then start trying for the angle of 10 degrees. So move it into the airflow a little bit. So it's hard to tell from the fish, but the body of the fish is trying to stay at that plus 10 degrees angle. And obviously a lot to be improved, but it does seem to be trying to do it. Give it a bit of a move, and it does try and do some movements back. Alright, pause there and load the next program. Now uploading the program where we're trying to maintain 15 degrees from a 15 degree set point. So this one was a little bit more difficult. I found that it tries to maintain that 15 degree angle there, but the further it gets away from the set position, the more sort of uncontrollable it gets. Definitely got a few thoughts on why that has occurred, but reasonably happy with how I've got it. We try and sort of turn it a little bit. Tries to stay, but yeah, definitely the further it gets away, it gets a fair bit more erratic. Just pause that, turn everything off, and discuss what I found. So yeah, during the tests, it was a lot of trial and error to try and get it to the point where it was even looking like it was trying to maintain what it was doing. As we saw there, and it did, when it was close to the set points, maintain relative stability. However, the further it got away, and with larger movements, it started to overshoot, which led to a loss of stability. The issues I think I had, so the overshoot was the major issue, which I verified by reading the error and error previous from the serial monitor. And you could see increasingly large readings when the sensor position was reading from the set point was increasing. I did get this variation somewhat stabilized, mainly using the KP variable. I did try and use small KD and KI factors, but they all resulted in a loss of stability, definitely. But yeah, definitely had difficulty balancing the point between where the system started oscillating with large overshoots and undershoots. When I reduced it, then I started sort of not having enough movement to effectively direct the system through the airflow. I noted that especially with this gyro, even though when the bias had been removed as per the tutorials, it stayed relatively close to 0 when the bias was removed, but it still definitely had some large jumps, like random jumps, which definitely was sort of throwing the system off, even though they weren't all the time. The loop time was definitely an issue to make the servo respond in a stable way, not being too violent, throwing everything off. I did utilize a if for else loop to try and smooth it out. It did work a little bit. I do think the way that the hinge is probably could be better. It's definitely introducing a bit of friction that was impeding that. I believe my system also had further complications because I was operating the servo motor from 90 degrees as the neutral point, which complicated how I was putting the output together. And finally, believe another contributing factor to the response issue was the system position was being obtained from the last position, not from the set point, which did make it a bit hard to try and get it to maintain its position from a set point, not from the last point. But all in all, hopefully did all right. And yeah, looking forward to the feedback. Thank you very much.